In Move, a struct is the building block for all custom data. Think of it as a labeled container that travels through functions intact. Whereas Solidity pushes you toward loose parallel arrays, a struct lets you pack every attribute of a concept, say a user profile, into one serialized blob. Because a struct carries no methods, logic stays in the module, creating a clean separation between data and behavior. Instantiation uses classic record syntax. User, name, age, email, name. The compiler lays fields in deterministic order for predictable hashing and low-friction proof generation. Most structs are boring data, but tag one with the key ability and it graduates to a resource, a first-class asset the chain treats like physical property. Unless you also add copy or drop, and you rarely should, this resource can never be duplicated or silently garbage collected. The only legal actions are explicit. Move it to a new owner, store it in another struct, or call a destroy helper you wrote. The compiler confirms linearity before bytecode ever lands on a validator, turning a bug class that once drained exchanges into a syntax error. Your IDE underlines in red. Abilities are permissions glued to the struct definition itself. Store is the default workhorse. You need it to persist an instance anywhere. Add copy when duplication is harmless. Add drop when you're fine with automatic cleanup. Finally, key signals the runtime to track a UID and allow object transfers. The beauty is composability. A priceless NFT carries key, store, never copy or drop. A user profile might use copy, drop, not store. An internal helper struct can live happily with store alone. By baking rules into the type, you sidestep runtime checks and telemetry overhead. Interacting with struct fields is straightforward. U.balance gives you the number. U.balance equals 0 requires a mutable reference to U. Under the hood, Move's borrow checker prevents two writers, or a writer plus readers, from coexisting, echoing Rust's proven rules. Destructuring is equally handy. Let user its name, age. U pulls multiple fields at once. When a mutable borrow ends, usually at the function's last use, the reference dies and other calls may borrow again. This compile time guarantee eliminates data races without slow runtime locks. Generics keep libraries DRY. A box works equally for SUI point resources and plain integers, as long as the type can live in storage. The compiler enforces the ability constraint you declare. Swap in a non-storable type and build fails. Nesting is legal and common. An invoice can embed a customer embeds an address, and so on, provided each layer lists store in its abilities. Sometimes you want a compile time tag, but no extra bytes on chain. Declare struct capsule, ask ID, UID radic. The phantom parameter helps the type checker, but produces 0 runtime footprint. Time to flex what you've learned. We add a second resource, supply, to track global issuance. Because only one instance should exist, we publish it to the shared object pool at address at 0x0. Any module function that touches it lists acquires supply, making side effects obvious to auditors. In Mint, to we borrow the singleton mutably, assert future total does not exceed the cap, then update and proceed to Mint. Notice that cpal point unchanged continues to use key ostwy store, while supply also uses key iketing store but lives in the shared realm, demonstrating how the same abilities behave differently depending on context. Compile and run init tact supply once. Subsequent airdrop jack yourself transactions now fail gracefully if the cap would overflow.